Good afternoon, dear students. How are you, my dear students? I'm fine. Yesterday class, we discussed preparation of hydrogen, only two types. The third type is remaining. Today's class we are going to discuss about third preparation of hydrogen, that means industrial preparation of hydrogen, and preparation of deuterium and tritium properties also. Okay, we can start this section from industrial preparation of hydrogen. So totally three types of preparation for hydrogen. First type, electrolysis of water. Then second type, laboratory preparation of hydrogen. Third type, industrial preparation of hydrogen. So third type is a large scale one, and you can it is affordable one, and economically it is good. In this method, we use here hydrocarbons like methane. We use here. What is the formula of methane? CH4. So CH4, it is treated with R. Here it's mixed with steam. Okay, steam means what? It's a hot water vapor. Okay, so if you heat some amount of water, then you will get some after boiling of that water, you will get some water vapor, that's steam. Okay, so steam, that means it contains water molecules reacted with the hydrocarbon. What is hydrocarbon? Which hydrocarbon we took here? Methane. Methane is passed through steam. It is mixed with the steam and it is passed over or reacting in the presence of catalyst. One catalyst, that is nickel. We use here catalyst as nickel. Because of this reaction in the presence of catalyst nickel, it's produced here carbon monoxide plus hydrogen. So we got the product hydrogen. Condition for this reaction, this temperature 800 to 900 degrees Celsius and at 35 atmospheric pressure. Steam reforming of hydrocarbon. So steam reforming of hydrocarbon. Hydrocarbon is treated with the steam in the presence of nickel catalyst at the temperature level 800 to 900 degrees Celsius and 35 atmospheric pressure. You will get carbon monoxide and 3 H2 molecules. So hydrogen is obtained from this process. So the same one, we have another process to getting the hydrogen. Steam is passed over a red hot coke. Another method, another process. The same method but another process. The same here, we used here steam. Steam is passed over red hot coke. Coke is a hydrocarbon. This is also a hydrocarbon. So now steam is treated with the hydrocarbon, or it is passed over with a red hot coke or hydrocarbon to produce carbon monoxide and hydrogen. So this type of carbon monoxide plus hydrogen is produced in this process. This gas or this resultant is generally known as, it's a water gas. Or you can call this is synthetic gas. or otherwise you can call this syngas. So it has three names: water gas, synthetic gas, syngas. What is the formula of syngas? CO plus H2. Syngas is the important one, and we use this for the synthesis of organic compounds like methanol, ethanol as a, and some simple hydrocarbons. So red hot coke, carbon. Okay, carbon. Red hot coke, carbon. Carbon, it is reacting, or it is steam is passed through red hot coke. Coke means that is carbon. So that carbon treated with steam. Red hot coke. So the temperature level 1000 degree Celsius, and the resultant carbon combined with oxygen, it's formed carbon monoxide, and the remaining hydrogen as a byproduct. So this is generally known as, or generally called, it is syngas. They may ask the questions like this: to write the preparation of water gas or synthetic gas or syngas, and maybe the questions like one words, write the formula of synthetic gas or syngas. It is an important part of this preparation. Totally 3 type of preparation you have. You just learn this, all the preparation, and the important preparation: industrial preparation and electrolysis of water. From this, carbon monoxide is converting into carbon dioxide with the treating of water in the presence of 400 degrees Celsius with the help of shift converters. We have 2 type of shift converters: iron and copper. So shift converters are shift converters catalyst. This reaction is generally known as water gas shift reaction. It's important. Water gas shift reaction, because we used in this reaction to convert carbon monoxide into carbon dioxide with the shift catalyst. That's why it's generally known as water gas shift reaction. This is water gas. Okay, water gas, right? Carbon monoxide is combined with water and heated 400 degrees Celsius in the presence of shift converter catalyst. So this is called shift gas, water gas shift converters, shift reaction. Okay, and the result of this reaction is carbon dioxide, carbon monoxide. Again, in the water, from the water it will get one oxygen, it's combined together and it form carbon dioxide. The remaining one hydrogen is separated out from this reaction, and carbon dioxide, which is formed from this water gas shift reaction, it is absorbed by the solution potassium carbonate, in a solution of potassium carbonate. So the reaction of absorbing carbon dioxide by the solution of potassium carbonate is given. Carbon dioxide is absorbed by solution of potassium carbonate plus K2CO3, potassium carbonate, and water. It gives 2KHCO3, K2. So 2K hydrogen. How many hydrogen are present? 2. So you can put here 2KHCO3. Here one CO2, and it is combined with the oxygen from H2O. So it's become CO2 plus 1O, CO3, and it's also contains CO3. So how many CO3 are present? 2 molecules of CO3. So 2 molecules of potassium, 2 hydrogen, 2 molecules of hydrogen, and 2 CO3. As you know already about the isotopes of hydrogen, First isotope, protium. You learn the preparation of protium. The next one, preparation of deuterium. Deuterium. Normal water contains 1.6 into 10 power minus 4 percentage of heavy water. So deuterium is generally known as a heavy hydrogen. It's a heavy hydrogen. So normal water contain 1.6 into 10 power minus 4 percentage of heavy water, and it is dissociation of protonium water. It's more than heavy water. So when the water is electrolysis, so like the electrolysis of water process, when water is electrolysis, hydrogen is easily liberated as a hydrogen is easily liberated from the water, but heavy molecules like deuterium is not easily liberated from the water. So first hydrogen is removing, then the electrolysis continues until the deuterium is liberating or getting the getting enriched water of deuterium. So the given process is explaining the electrolysis of heavy water. Two molecules of D2O. D2 means H2O will denote here. H is a protium isotope, D deuterium isotope. That's why we denote a D2O. Okay, so D2O is electrolysis process. What is the electrolysis process? Get amount of water in with the alkali or acid in electrolytes contained with keeping anode and cathode passing through the electric current through this electrolyte. You will easily get the ion exchange and transfer of electron, acceptance of electron. It's produce liberating of hydrogen and also the liberation of deuterium at last. Okay, so D2 plus O2 is produced. How many deuterium is present? 2 into 2, 4. 2 into 2, 4. Okay, and 2 oxygen. So deuterium is separated out by the electrolysis of heavy water. Next process, preparation of third isotope, tritium. You know that tritium is an radioactive element and it is present only in trace amount. So we can prepare this tritium artificially by bombarding the lithium with slow moving neutrons in a nuclear fission reaction. Why we prepare this in a nuclear fission reaction? Because it is an radioactive element. Radioactive, and only trace amount of tritium is occur. So that trace amount also we are prepared from the nuclear fission reaction. For nuclear fission, lithium is bombarding, or it is react with slow moving neutron. It's produce tritium isotope with the resultant of helium and tritium isotope. Only the trace amount is produced by the nuclear fission reaction of lithium with slow moving neutrons. Preparation over. Next, properties. We have two type of properties: physical and chemical properties. Physical and chemical properties. First, physical property. It is a colorless one. Hydrogen gas is a colorless, odorless, and tasteless. This is lightest compound because it is located in the top of the modern periodic table because of the atomic weight and their number of electron in it. So this is lightest one and highly flammable gas. It can flame high flammable gas. It is a non-polar diatomic molecule. Non-polar diatomic molecules means hydrogen plus. So they cannot make the different poles. They can make only a same pole, positive and positive. One pole contain positive and another one end contain positive. So they are non-pole diatomic, two atoms connected together. So these two atoms are non-polar molecules. We can liquefy this, we can convert this gas of hydrogen into liquid under the very low temperature. Gas into liquid by low temperature and high pressure. So we have some condition to convert this hydrogen gas into liquid by low temperature and high pressure. So hydrogen is a good reducing agent. We use this hydrogen to reduce many reaction as a reducing agent. We can use this as many process. Next is chemical properties. Hydrogen has some chemical properties like oxidation, reaction with halogens, reaction with metals, and reaction with addition reaction or the reaction in the saturated compounds. So first we can look at first process is oxidation, or the first property, chemical property of hydrogen is oxidation. Hydrogen is easily react with the oxygen to give water, because we already know that formula of water is H2O. Hydrogen is combined with the oxygen, that's why it's produce water molecule. So the oxidation reaction of hydrogen is an explosive reaction and it's release lot of energy because of the reaction between hydrogen and oxygen. So this energy, explosive reaction energy, we use this in the cell to generate electricity. Fuel cell, we use this. So the oxidation reaction for this hydrogen, two molecules of hydrogen is reacting with oxygen and it's produced 2H2O, water molecule. So this is oxidation reaction. The second chemical property of hydrogen is reaction with halogens. What are the halogens, you know? Fluorine, chlorine, bromine, iodine and astatine. Okay. Hydrogen is reacting with halogen and it's produce different compounds in different conditions. So first one of the reaction with halogen in hydrogen, reaction with the fluorine and hydrogen, it takes place in the dark room that reaction between hydrogen and fluorine is an explosive valence reaction, and the reaction with hydrogen and chlorine, it's under the room temperature and under the light, it is also the explosive reaction. And when hydrogen is combined with the bromine on heating reaction, the reaction that is also same like previous. When hydrogen is combined with the iodine, this is a photochemical reaction, and the overall reaction for this hydrogen and halogen reaction with the product of hydrohalide, H2 hydrogen is combined with halogen. So this halogen we denote X. X means halogen. So X2 produce 2H X. X is the reference of fluorine, chlorine, bromine, iodine and astatine. It may be HF, HCl, HBr, etc. Third property, chemical property of hydrogen is reaction with metal. Reaction with metals. Oxidation state of hydrogen is generally known. This is oxidation state of hydrogen +1. But it has, because of this oxidation state, it has the tendency to react with the reactive metals like sodium, lithium, calcium, and it can produce the hydride of the particular compounds, the reactive metals. For example, 2 lithium is combined with H2, 2 molecules of hydrogen, and it's produced lithium hydride. Lithium hydride. Two molecules of sodium, it is a reactive metal, and it's combined with hydrogen, it's produced 2NaH, sodium hydride. Generally, hydride is the hydride, or this alkali hydrides have the oxidation state. Oxidation state is -1 because of the combination of hydrogen with the reactive metals. Next property, the above hydrides are using as a reducing agent. Generally, hydrogen is a reducing reagent, so it's behave as a reducing agent in the synthesis of organic chemistry, and we can use this to prepare the other important hydrides. To using this lithium hydride, we can use this to produce lithium aluminium hydride, and also the another hydride, sodium borohydride. So hydrogen is using here, hydrogen or lithium hydride or sodium hydride are using here to prepare lithium aluminium hydride, sodium borohydride. Again, we took this resultant lithium hydride and sodium hydride to produce the another hydride. 4 lithium hydride with AlCl3. Now these two are combined, they produce Li, AlH4. This is lithium aluminium hydride. Lithium aluminium hydride. The remaining 3 lithium chloride. So totally 4 LiH and AlCl3. 1 Al hydrogen, totally 4 hydrogen, 1 lithium from this 4 lithium. So the remaining 3 lithium, 3 chlorine. Hydrogen is fully balanced with this lithium aluminium hydride. Then take sodium hydride. So 4 molecules of sodium hydride combined with B trimethyl borate. The name of this compound, trimethyl borate. So BOCH3 thrice gives Na, 1 sodium combined with 1 boron, then 4 hydrogen. So 4 hydrogen. This is called sodium borohydride. Sodium borohydride. So the byproduct is 3CH3 ONE. Okay, CH3 3 times, O 3 times, Na remaining 3 because 1 sodium is combined with 1 boron and 4 hydrogen. Next chemical property of hydrogen, addition reaction. In the addition reaction, hydrogen is also reacting as a reducing agent. When we use this hydrogen and nickel as a reducing agent in unsaturated organic compound, they can form saturated compounds. Example for this, we took here acetylene. What is the formula of acetylene? CH triple bond CH, one organic compound. It is treating in the present, or it is adding hydrogen in the presence of catalyst, reducing catalyst nickel. Now, the reaction between this organic compound acetylene and hydrogen in the presence of nickel, it breaks this bond. From this triple bond, one bond is breaking. Okay, so because of this bond breakage, one hydrogen, from that 2 hydrogen, this bond between this 2 hydrogen is broken, and now 1 hydrogen is attached with carbon, and another hydrogen is attached with another carbon, and the product of this reducing reaction is CH, and this hydrogen is attached with this carbon, right? So CH double bond. Here double bond because this bond is broken by this nickel. Then CH. Here you have CH and it is attached with another hydrogen. You can write this compound like this: CH2. 2 hydrogen are bonded with carbon. So CH2 double bond. This carbon is double bonded with another carbon containing 2 hydrogen. So the name of this compound is ethylene. Double bond, ethylene. Then again, treating this ethylene, reducing this ethylene with the presence of nickel, or adding hydrogen in the presence of nickel. What will happen? The next bond is getting break, and the hydrogen from this hydrogen molecule, one hydrogen is attacked with one carbon and another hydrogen is attacked another carbon, and it will become CH2 single bond CH2, this CH2. Then again one hydrogen is attacked in this carbon, right? Hydrogen, you can write like this, or otherwise the compound CH3 2 3 single bond CH3. So the name of this compound is ethane. This is addition of hydrogen in organic compound in unsaturated compound to form the saturated organic compound. So today's topic over. Thank you, students.